Okay, so remember when we looked at congruent triangles?
No.
We had 4 different tests. Were you actually filming?
Yes!
Okay, so when we did congruent triangles, we had 4 different tests to check if they're congruent. What are they?
Ooh, SAS.
SAS?
RHS.
RHS?
SAS.
AAS?
SSS.
Quiet. We are going to do some tests for similar triangles, only just to be mean, we're not allowed to use abbreviations, we have to use the whole sentence. But we can cope, because at least we got to use abbreviations for congruent. So similar triangles also has some tests, but we're just not going to call them AAA or anything. So the first rule is actually kind of AAA, but without calling it that. So we're going to have the 4 tests. So,
Foretaste.
first test is that you have all angles equal. If all the angles are equal, you know the triangles are similar, okay? But we have to write all angles equal. Actually, there's a word that says all angles equal without writing that, and the word is equiangular. We want to be tricky. So we're going to have 2 shapes.
2 shapes.
They are not the same size. Is that forward and wide? Yes.
They're like what's it called? What's it called?
That's the same, and then this one's the same. What is it? Now, angles are kind of cool because as soon as you have Charlie, as soon as you have 2 angles equal, then we've already got equiangular. Why?
Because they're equal in most ways except for...
You need to work up on your
Because if I, say I knew this one was 60, this one's 60, this is 40, this is 40.
It's the same scale factor.
Because
It's just
of
been
what?
enlarged.
How do I know that this one would have to be the same?
They add
It's been
218.
enlarged.
Yes, well done. Lawrence has got it.
Enlarged.
Charlie?
What's that word?
Diabetes.
Yeah, that's it.
Okay.
Dilation.
Dilation, yes.
Dilate.
That's not what we're talking about. The angles in a triangle must add up to 180. So if you know this is 60, this is 40, and this is 60, this is 40, okay, then what's this missing one got to be?
80, 60 and 40.
Minus 180, yeah.
720.
What's 60 plus 40?
100.
And so what angle's missing?
80 degrees or
So both of them would have to be 80. So as soon as you have 2 angles equal, okay, you know they're similar.
They look nothing like
Guaranteed.
80.
Okay, next rule is similar to SAS, but we're not going to call it SAS. We're going to call it side, angle, and side. But the sides are not equal.
ASS.
The sides are not the same, but both pairs of sides must give the same ratio. Okay, so our second rule is 2 sides in the same ratio and the included angle equal. Okay, so we're not calling it SAS because that's a congruent. Come on, Charlie, please concentrate. Okay, so say this was triangle ABC, and this is triangle DEF. Then I might know that AB over DE is going to give the same ratio as BC over EF. So it gives the same ratio, and the angle in between them is the same. Alright, so they don't quite look the same, but pretend they're the same.
True. I pretend.
So that's our second rule. That 2 sides are in the same ratio, and the included angle is equal. Alright, rule number 3.
Rule?
Wait, can you go back for 1 second?
No.
Right, then you'll see.
You're right. Okay, rule number 3 is all sides sides are in the same ratio?
SSS.
We're not allowed to call it that.
Equivalent.
No, we're just going to call it all sides in the same ratio. Right, so I've got this triangle here, which I'm going to call LMN, and this triangle here, boys, stop being silly. Call it JK, whatever I'm going
Miss, have you heard of the Illuminati?
Can we not get unfocused, please?
A lot of
Right,
triangles here.
so
Matthew, it's a
this, these triangles are not the same size, it's clearly bigger, but each matching side has to form the same ratio. So ML over KJ, okay, has to form the same ratio as MN
Okay,
over KF.
KF.
Oops, I wrote that wrong.
Which
Which equals the same ratio as LN over JF.
JFK, eh?
Just JF.
JFK.
Okay, so they all have to give the same scale factor. Okay, that scale factor might be like 3 times bigger, or it might be 1.2 times bigger. It doesn't have to be a whole number. Okay, but that would be all sides in the same ratio. There's only one more rule. And the rule that we're looking at is kind of matched with the RHS rule from congruent triangles. So it's still going to be a right angle, hypotenuse and a side, but my hypotenuse and the side are not equal. They are in the same ratio. Okay, so we've got right angled and the hypotenuse and one side in the same ratio.
Are you writing this?
Yes, you are.
Wait, are we supposed to be writing this the whole time?
Yes, you are.
Can you go back up?
No. You'll have to catch up
Oh,
later.
yes, I didn't even finish writing that.
So, I'll
There we
put
go.
it there. We all good?
Yeah.
So I'm going to have a little one here and a big one here. I'm going to call this one
RHS. RHS.
FED, and we're going to call this one QRS. Now they've both got to have a right angle. Now it needs to be the hypotenuse, Lawrence, leave it alone, and any other side. So the hypotenuse is ED and RS. So ED over RS has to equal one of the other sides. It doesn't matter which one. Okay, I'm just going to do the basis for now, FD on QS, but if you had the other one, that would be fine. FD on QS. Okay, then they would be in the same ratio. Okay, so it doesn't matter which side you have, whether it's these ones or these ones, as long as you have the right angle of the hypotenuse and one of the others in the same scale. Yes?
How do you find out that they're the same ratio?
You'd actually have to be given their numbers. So I might tell you this is 2 centimetres, this is 5 centimetres, this is 4 centimetres, this is 10. And you actually work out the fractions. If the fractions are all the same, then you know they're in the same ratio. So you actually have to give you numbers to work with. Because at the moment that doesn't tell you anything about the shape. They'd actually have to give you numbers. Yes, Abby?
Are we going to have to remember all of these for the total test? Or will they just be, will you use this like a formula sheet kind of thing?
No, you're going to have to remember them.
What? Yeah, I'm failing that test.
Oh, you're not.
video on YouTube.
Okay. So, basically, you're going to look at some triangles, you're going to be checking which of the rules works, and make sure that you have your things that are equal. We're going to look at exercise, where is it? 8G from the textbook. Now, once you know things are similar, you can use that fact to find missing sides or missing angles. So if I knew that this one was twice as big, and I knew these ones were in ratio, so let's put some numbers on there. Say I had
4.
a 2 there, a 3 there, and a
5.
6 there. That's not actually true, but let's pretend it is. And then this one was 12, and this one
9.
was
6.
So can we see that these are clearly doubled?
Yeah.
So to find this one,
You just,
you find the missing one using the scale factor, using the fact that this
Has to be
fraction is
4.
going to be twice as big. So it has to be 4. Alright, in reality, those triangles don't exist.
Yes.
Why not?
Because they're not
They're
real,
not
they're on
congruent.
screen.
Very funny.
Because they're not congruent.
Why? Why do I know this doesn't exist?
Not common.
I don't know.
It's a right angled triangle. What rule must all right angled triangles obey?
2 squared plus 3 squared equals
2 squared would have to.
Pythagoras'
so it
theorem.
has to satisfy Pythagoras, and that doesn't, does it?
No.
Because 2 squared
No, we
plus 3 squared is what?
It wouldn't be
5
right
squared.
angle.
Five.
Yeah, no.
9
Yeah,
squared.
yeah.
2 squared is 4, plus
Yeah.
3 squared is 9, 4 plus 9.
Yeah,
Equals
yeah.
13.
And what's 6 squared?
6 squared equals 36.
Whoa!
So that triangle doesn't exist.
It wouldn't be right angle though.
It would exist, but it wouldn't be a right angle, you're right. Okay? So I could create, actually that doesn't even exist, because 2 and 3 would not possibly reach. So if I had a 6 centimetre line, and I drew 2 centimetres this way and 3 centimetres that way, it doesn't actually reach. Okay? You cannot create this triangle. It does not exist. It doesn't, you cannot even draw a triangle like that.
I can.
Okay?
20 bucks.
You can't.
Still lost.
You draw a 6 centimetre line and you have a 2 centimetre and a 3 centimetre. They can't join.
It physically can't.
Just physically cannot create a triangle.
Yeah.
Physically
It
can't.
needs,
Promise
the
you.
angle needs to be
Alright.
5.
You can't do it.
I think you lied to me.
How
No, I'm telling the truth. You really can't do it.
So there's
You,
1
well, then it wouldn't be 2 and 3 anymore.
Bucks.
Alright, let's move on. Let's try some questions. Can you stop the video?
Oh,